Alright, this video is about how to work pH problems. All of the equations that we're going to need are here on the screen. We have up here two ways that we can work things. We have how to find pH and how to find pOH. And as you can see, both of these are the negative log of the concentration of a particular item. When you see the brackets, that's referring to concentration, and usually concentration is given in molarity, and that's going to be the case for here. So we should see some number and then a capital M, like for molar. Okay. Then right here we have the relationship between pH and pOH. If you add them up together, it equals 14. And down here at the bottom we have basically how to work in reverse. You have how to find the concentration of the H and how to find the concentration of the OH. Both of them are 10 raised to the negative whatever, like the negative pH for the H's or the negative pOH for the OH minus. So let's see what that's going to look like. Alright, here is an example of, oops, let me switch back over. Here's an example of some problems that we're going to work. So what we want to do is we want to work through just, I'm going to skip around through a couple of these. This is page 106 if you have your notes and you're following with me. So the first one says that we have a solution that has a hydrogen ion concentration of this. What this is my concentration of the hydrogen ion right here. And it wants to know what is its pH. Well, the only way to do this is to use the pH equation, which is the negative log of 3.2 times 10 to the negative 9th molar. So what you're going to do is you're going to put that into your calculator. You need to put it in exactly as it appears. Put in negative and then log and do the 3.2 to the negative 9th. And you will get an answer of that the pH is 8.4948 and a bunch of other digits. Now, if you're doing sig figs, and we are, the number of sig figs that you use with pH is based on the number of digits after the decimal. So we're looking just on the right hand side. The 8 doesn't count because you have to have some number at the beginning. So this has 2 sig figs in it, so we get to keep the first 2 digits, and we're going to be cutting it off right there. So that means our final answer will be 8.49. Alright, let's look at this third one down. What is the pOH of a solution if the concentration of OH is this? Well, we're just using the pOH equation. That's going to be the negative log of our concentration here, which is 2.7 times 10 to the negative 3rd molar. We're going to put that in the calculator, again, exactly like it appears, negative log, and then we're going to have of 2.7 times 10 to the negative 3rd. And you will get an answer of 2.5686 and a bunch of other digits. Okay, again, this has 2 sig figs, so we're going to give it 2 decimal places to represent the number of sig figs. We're cutting it off right there. That means the 8 is going to round my 6 up, so my final answer will be 2.57. And again, this is the pOH of this one. Now keep in mind, we've talked about in class that, pH and pOH together, they're opposites of each other. So, that's how they add up to 14. If the pH is 8.49, then the pOH is going to be like 5 point something. It'll be the difference between those. Now, here, what's the pOH given this pH? Well, I can't use this equation this time because I don't have the OH minus concentration. But we do know that pH plus pOH, like I just said, adds up to 14. So we just simply plug them in. 2.8 plus pOH equals 14. And when you do the math, you'll get 11.2. It's going to be my pOH. Now, if we move on down to this next little set, I'll do a couple of these. They are asking, or this question asks for me to tell if it's acidic, basic, or neutral. Well, I would recommend that you do it based on the pH scale, because on the pH scale that you're going from 0 to 14, you've got 7 in the middle, you're an acid if you're on the 0 to 7 side, and you're a base if you're on the 7 to 14 side. Anything less than 7, I don't care if it's 6.99, is an acid, and anything greater than 7, even if it's like 7.001, is a base. So if we are given the concentration, you're going to have to find the pH. You're going to have to do what we did up here in order to do it. So for this particular one, you're actually going to have to do the negative log of 5.3 times 10 to the negative 7th to see what we get. I have the answers to these, but not in front of me. So I get that this has a pH of 6.27 and a bunch of other things. I don't really care about this because it didn't ask me for the pH. It asked me if it's acidic, basic, or neutral. If it has a pH of 6 anything, then my answer for this one is that this one is going to be acidic. Okay? The next one, well, this one's easy because look what they give me. It gives me pH right off the bat. A pH of 3 is down here between 0 and 7, so this one is also going to be acidic. Alright, my next one. Excuse me. The problem with this one is that it gives me the OH minus. And there are other formulas that you could use, but, you know, just for the sake of simplicity, let's deal with the 5 that we have looking over here at, oops, let's cancel this. I don't mean to do that. Looking at the ones that we had before, we've got the pH and the pOH ones. So I recommend that what we do first is we find the pOH. That's the negative log of 9.3 times 10 to the negative 9th for this case. Let's see. And we get that this has a pOH of 8.03 and some other numbers. But this is pOH. This is the pH scale. You can do this one of two ways. You can know that it's backwards, that in terms of pOH, an acid would be from 14 to 7 and a base would be from 7 to 0, like they're the complete opposite numbers. Or you can use this equation that we used right here, and you can do the math and you can find that the pH of this thing is going to be 5.97, and what that'll let us do is go, okay, 5, that falls between 0 and 7 on the pH scale. So once again, this is going to be acidic. This next one, if we have a H plus concentration of 1 times 10 to the negative 7th, that means its pH is going to be exactly 7. And if its pH is exactly 7, we have something that's neutral. This one, we're going to go back up to this equation again, that pH plus pOH is 14. What that means is that my pH value, oops, I'm still in red, oh well, is going to be, oops, what am I doing? Is going to be, right there, 11.5. And if it's 11.5, then that's pH, then this one's going to be basic. What am I doing? I don't know. If you're with me, you're probably going like, what is she doing? 10, what, 9.5? I have no idea. I'm thinking I'm doing other problems. I can't add, because it doesn't add all the way out. Okay. My bad. We are still at a basic pH, but apparently I had a mental moment with math. Okay. I am going to clear this screen because I want to work some problems at the bottom of the page. So if you will go to the bottom of the page, and we're looking down here at this little section that's asking me the questions in reverse, just to make sure that we understand what to do. I'm sure there was a faster way, but well, here we go. It says, what is the concentration of the following solutions? It's wanting the H plus concentration. Well, we had two formulas for this. We had the one where we could do the H plus, and we had the one where we could do the OH minus. Both of them are 10 to the negative P whatever, like 10 to the negative pOH, or for this one, 10 to the negative pH. So they give me pH. So we're going to do 10 raised to the negative 8.2. And that's seriously what I put into my calculator. 10 and then raised to the negative 8.2. You have to remember the negative. If you don't, it gives you a drastically different answer. So for this one, I will get 6.3 times 10 to the negative 9th molar. My calculator says 6.30. You can see what it says right here. It says 6.30957, but I'm going to choose my sig figs based on the fact that this has one decimal place. So, oops, actually I shouldn't have done that. Then this should have one sig fig, and I'm thinking one decimal place. What that means is we need to take the 3 off of it. It should just have one sig fig. So we're actually just going to say 6 times 10 to the negative 9th will be our answer. 1 sig fig for one decimal place. Okay, the pOH. Well, if it's OH, this time we're going to use this equation, but it's the same idea. We're doing 10 raised to the negative 1.5. So 10 caret negative 1.5, we get 0.0316 as my concentration of, this is going to be my concentration of the OH minus. Now, there is a formula that you could use in order to relate the concentrations together. However, it's on your reference table. I just prefer to work around that. If I do this, I found the concentration of OH minus, but if you go back and look at your question, it's asking you for H plus. So what that means you're going to have to do is you're going to have to find the pH. If the pOH is 1.5, that means my pH is going to be 12.5. So if that's the case, then I need to do 10 to the negative 12.5, and you're going to get a vastly different answer. You're going to get a concentration of 3.16 times 10 to the negative 13th. This is going to be my answer over here because it goes with the H, and that's specifically what my problem asked. Now, this has one decimal place, so we need one sig fig. So we're going to round it down to 3 times 10 to the negative 13th molar. And there will be my final answer. Alright, that's the gist of it.